In today's video, I'm going to show you how to vibe code an Android robot using Claude Code. This robot can listen, talk, and follow your commands.
Can you move forward?
The best part, it runs entirely locally using the Gemma 4 model, featuring offline voice recognition and text-to-speech.
Can you sing a song? Can you please stop?
Now, let's get into it. Let's vibe code this together. First off, let's get the Android UI ready by creating the robot's face. I'm using Microsoft Paint here, but any tool you're comfortable with will work. Then, I drop this image into ClaudeCode and let the coding agent generate the Android app for me. After the code was generated, the files ended up in the wrong folder. I'll just ask the agent to move everything to the correct location for me. Now, we'll import the source code into Android Studio. It'll take a minute to download the dependencies and sync the project structure. To test the layout, I'm going to launch the Android emulator. I won't be using a physical device for this phase, as the emulator is much faster for quick UI iterations. When I tried launching the app, the code compiled, but a few errors popped up. Alright, let's ask Claude Code to fix them. After a bit of back and forth, Claude Code finally fixed the errors and we're ready to launch the app. The app launched, but the robot's face looks a bit too simple. I'm going to ask Claude Code to fine-tune the UI and give it a more polished look. After experimenting for a bit, I've decided to use Paint to draw the exact layout I want. I've found that giving the coding agent a visual guide works much better than just using text. While the coding agent handled the heavy lifting, I just kicked back and listened to some music. By combining visual guides with our prompting, the coding agent can fine-tune the UI, making it better and better with every iteration. Now I'm asking the coding agent to add some test buttons so I can check the robot's facial expressions across 4 different states: idle, listening, thinking, and speaking. After a bit of prompting, the robot's face and its expressions finally meet my expectations. Now, moving on to the second part, giving our robot the ability to hear. To do this, we need a speech recognition model. I know Whisper is a top-tier option, so I'm looking for an open-source implementation that runs natively on Android. After some searching, I found a solid repository that fits our requirements perfectly. I'll clone the repository and open it in Android Studio. I'm switching to a physical Android phone for this, as testing microphone heavy features like Whisper is much more reliable on real hardware. I want to be 100% sure that the speech recognition runs smoothly on an actual device before we move forward. After making a few modifications, I confirmed that WhisperM is working perfectly on my device. Hello, what is the weather today? Now I'll ask the coding agent to cherry pick the ASR logic from that repository and integrate it into my robot app. After grabbing a quick drink of water while the coding agent processed everything, I'm finally ready to compile the Android robot app. Alright, everything is linked up. Let's deploy the app to my phone and see if our robot is ready to listen. Hello, how are you today? Hello, how are you today? Alright, it is working. Time to save our progress. I'll initialize Git and create the initial commit for the project. Actually, I'll have the coding agent do it for me too. The next step is adding voice activity detection. This will allow the robot to automatically sense when I'm speaking and trigger the transcription process. I found an Android V repository on GitHub. I'll clone it and test it out to see if it can automatically detect speech. When I first tried to compile the VAD project, I ran into a few errors. I handed those logs over to Claude Code, and it helped me troubleshoot and fix the build issues. Finally, I've got the VAD app running on my Android device, and we're ready to see if it can detect my voice.
Hello, hello, hello. Hello, how are you?
The VAD test was a success. Next, I'll ask Claude Code to grab the relevant parts of that code and bring them over to the main robot project. With the coding agent done, I can finally run the robot app with integrated VAD. Let's see how it handles my voice.
Hello, can you hear me now? Hello, can you hear me now?
It looks like the integrated code isn't working quite right. The VAD is running, but nothing is being transcribed. Let's ask ClaudeCode to find a fix. Now, let's try the app again with the fix and see if it actually works this time.
Hello, can you hear me now?
The VAD is functional, but the stop trigger needs a bit of fine-tuning. I've asked ClaudeCode to fix the logic so the transcription wraps up properly. Now is the perfect time to make another commit and save our progress. It's always better to safeguard the work once the core features are stable. Now it's time to give the robot a brain. I'm going with Google's Gemma 4 since it's optimized for mobile, and I'll be setting it up via the AI Edge gallery. First, I'm going to clone the Google AI Edge Gallery repository. I don't actually need to compile and run this specific repo because I've already tested the app version on my phone and it ran perfectly. I'll have Claude Code extract the LLM download and inference logic, then integrate it into my robot's flow from voice input to AI response. And I'll just wait for Claude to do its thing and complete the integration. Now, let's compile the project and run it on my phone to see the new brain in action. It looks like I still need Claude Code to iron out some compilation errors before the app is ready to be installed and run on the device. It looks like the compilation was successful. Now, let's see if it actually works on my smartphone. First, the app has to download the models. These files are far too big to bundle directly into the app's asset folder. Once the models finish downloading, we reach the robot's main page. It'll take about 20 seconds for the model to fully load into my smartphone's memory. Now it's finally time to test how Gemma 4 responds to my questions.
Hello, can you hear me?
The latency on the 4 billion parameter model is a bit too high for real-time conversation. I'm going to switch to a smaller model to improve the response time. I'm having ClaudeCode update the logic to swap in a lighter model so we can get faster response times. Now, let's install the app on my smartphone to test out the 2B parameter model. It should be much faster than the 4B version.
Hello, what is the weather today?
That's much better. The response time is significantly faster now with the 2B model. Alright, let's add a voice to the robot so it can talk back and give us detailed verbal answers to our questions. I'm having Claude Code set up the text-to-speech feature so the robot can finally speak its mind. The code is ready. Let's run the build and test the new speech functionality. It says no TTS engine found, so I'm going to ask Claude Code to help me troubleshoot this. Claude Code has finished fixing the issue. Now let's try it again. Alright, I can see the TTS engines now. Now, let's check if the robot can finally talk.
Hello, how are you today?
I am doing well, thank you for asking. I am currently operating at peak efficiency and ready to assist you with any questions or tasks you may have. How are you doing today? And what can I help you with?
The robot can talk, but there are two bugs. First, it's repeating answers 3 times. Second, it's listening to itself and looping. I need to stop it from answering its own voice. Time to let Claude Code work its magic on these issues. It took about 20 minutes and several rounds of testing on the real device, but Claude Code finally fixed the issues. Let's check the results and see if it's working.
Hello, how are you today?
I am doing well, thank you for asking. I am currently operating at peak efficiency and ready to assist you with any questions or tasks you may have. How are you doing today? And what can I help you with?
It's officially working. We now have an Android robot app that can listen, think, and talk. And the best part is, it's running 100% offline on this device. We're going to wrap up part 1 here as my weekend is coming to a close and a busy work week is ahead. I'll be back with part 2 as soon as I can. Thanks for watching. If you found this interesting, please hit that like button, subscribe for more, and drop a comment below to let me know what you think.